Hi, I'm Barry Treleaven. Finally a voice to the name. We've been communicating through emails and also the course itself, and so I get the concept that you're getting a little bit used of me, but now we've actually got a situation. This is my first ever sound recording, so we'll just see how we go. Assess timber frame design, which is our topic that we've been studying over the last 6 weeks. We've worked very diligently on making sure that we understand all the componentry in a cut roof, and these following slides are all to do with us actually working out timber framing sizes, also constructing a roof layout, so therefore we can then calculate where our different timber members go. And so this will be something to make it a little bit easier for you guys to actually work through in an external fashion. How do we find the information? First arrow point, the layout matches page 47 in the roof framing workbook, which is within the roofing panel. The second point is the PowerPoint presentation is to assist students in the selection of timber sizes and table readings from the layout. To understand everything about using span tables, I strongly suggest that you study the PowerPoint using span tables, and you can find that within the course information. This is absolutely essential before you start working out figures. The fourth point is when you actually have a look at these plans, check and see that the layout is suitable. Wall frame layout. This matches everything that you would have seen on page 47. We've taken away all the other material, all the dimensioning or anything like that, so that we just see the bare walls. We will also be using this particular slide and enhancing it when we work on walls after the floor frame. This section has all the brickwork laid out, and quite simply, what are we talking about for brickwork is a cavity and brick of 150mm around the external diameter of the wall frame. Windows and doors. The blue shaded sections are actually showing the windows. It's very difficult to actually see the construction process, but generally on a wall frame, we have 40mm cavity, 110 brickwork. So that means that the windows need to be packed off of the outside line of the wall frame by 42mm. And we do this by actually fitting a 42 by 35 around the perimeter of the window opening, and then fitting the windows onto that, which really means that the fin of the window runs against the back of the brickwork. Stud layout. Generally on a roof like we have here, which is a 4-hipper, the first stud that is set out on the job is the half span of the building structure. So in this case, that's around about 7.7 meters. Divide that by 2, and then you would actually move that along, and that would be your first stud. And the reason for that is that that stud sits underneath the first pair of common rafters. Okay, at this stage, when you look at this drawing, the scale is very small, but you can increase it in size, and you'll be able to tell where the studs are. Why are we using studs? More than one either side of a window. That's all to do with lintel load and also wind load. And when we get into wall frames, that will be actually made more clear to you. Ceiling joist layout. This is quite unusual in this particular layout plan. Generally, we would always have ceiling joists running across a building and connecting to the rafters, and we do have over the main bedroom some ceiling joists running in the opposite directions. So that will be explained to you more fully as we go through the course. We also have the cross trim above the walls, and the reasoning for this is we must connect the walls securely to the ceiling trim to assist in our wind load. Generally, minimum or maximum span for ceiling joist is 600 centers, which means that we actually have a unsupported distance of 565 mil at either end and both sides of this building. We especially where the ceiling joists run in the opposite way to what is standard, we have jack ceiling joists, and the reason for that is so that when we fit out and install rafters, the rafters actually clear the ceiling joist. As you can see, breaks this down really clearly, but this is the first part that you would actually have to calculate, is the span of the ceiling joist, also the span of the ceiling joist running, in this case on the slide, vertically, what that distance is, or do we actually need to fit some other beams in here to enable us to use a reasonable size or a cost-effective size ceiling joist such as 90 by 35. Hanging beams. Hanging beams support only ceiling loads, and so their function is to pick up the ceiling joists, and where their span is too long, then what we actually need is to fit a hanging beam. My solution for maintaining the coupling of the wall frame over the bedroom where the ceiling joists run in the opposite direction is to run a full length hanger from one side of the wall frame to the other. The other hanging beams basically split each room into two equally wherever possible, and in this case we have a very simple wall frame layout, and so you will notice that everything there is parallel, and when you increase the size of this drawing, you'll even see where I've put in the soldiers which actually connect the hanging beams to the ceiling joist. Roof timbers. The light grey, partially blue, I guess, colour on this layout plan shows you first of all the common rafters, hip rafters, creeper rafters, ridge, fascia, and I have not included the roof purlins because this drawing is now becoming even more and more busy. And that is the reason that I've actually put this through in steps, because you would be looking at this and ending up cross-eyed. So when we actually see this layout, we can actually see that I have also not put in bracing, and that would be an additional component. But seeing that we're working out timber sizes, that is more important than the bracing at this stage. Under purlin, so we have a very pale aqua, almost a dirty aqua color, but you can see it generally. It's at the halfway point all the way around the structure, across and down, and the circles indicate where we're going to actually be putting some strutting, and that will be shown in the next slide. The reason for fitting under purlins, it's a point of support. Our rafters then go from being single span to multiple span, so they have multiple points of support. It means a smaller member size to cover the span for the job. Fan struts. Fan struts are an economical way of extending the distance that an under purlin can span. Also, it aids in the situation where an under purlin cantilevers, and you will find within your code that it has a figure of 25% of the backspan, and so we need to actually look at that really carefully. And so on the layout here, We've actually got a multitude of walls that I could choose. There is one vertical strut, and that is the bottom left hand side, and so I've just left a little circle over there, and because of the fact that the vertical strut goes underneath the underpurlin, you won't see it, so therefore we've just got a circle. I need you to actually look at this really carefully. Have I missed anything here? Collar ties. Collar ties perform a valuable task in a roof. Their function is basically centered around coupling, and so they couple the roof at the halfway point. Generally, collar ties are placed above an underpurlin and securely fixed by two 70mm nails into the rafter, and generally the chippies will actually put a fixing into the underpurlin as well. And so when you look at a roof side on, and you would have noticed in the assessment quizzes 3A and 3, one of those I actually put in and ask, what does coupling do, and what are the coupling members? And they are the ceiling joist and the collar ties. Labeling. One of the most important components of any plan. Needs to also have the window sizes, and you can see around here the window and door schedule. You can also see the window and door numbers around the outside of the plan. You can also see the dimensions. So we've got an overall external wall size of 7 meters 770, and from that we can reduce that by 300, which is our brick and cavity, by 2. Off of that to give us the outside dimensions of the wall frame layout. You'll also notice on the right hand side I've done an elevation of the roof. It's 30 degrees, and I've also given you the sizes of the span of the rafter, and also the length of the rafter, and also the length of the eaves overhang. And so that will be very valuable for you when you're calculating your timber sizes, because you will be looking at tables where it requires to know what the eave overhang is. I hope this will help you, and now you can put this into practice using your span tables, and you need to use the current ones. And by all means refer back to your referencing on how to use the span tables to come up with all the sizes. The addition to this PowerPoint is I will be opening another quiz, and this quiz will relate to this PowerPoint only. And so once you do that PowerPoint and you follow through each question, you can then refer to each of the slides. And so, for example, if we're working out collar ties, you then need to actually look at the collar tie tables and then work out what size we can use. And so it's a little bit of a process, but once we do this once like this, at the end of the course, you will actually have another one of these to do, but you will be actually filling in all the details. You will be actually laying out all the rafters, etc., so that we can end up going, right, this is what I need to have to actually calculate the timber sizes when we assess timber frame design. Thank you.